Okay, so before we get too heavy into trig and the theory of why everything works, I wanted to take this week as an opportunity to show you why those trig functions, sine, cosine, and tangent, are actually really important in real-world application, okay? And so we're going to kind of leave behind the whole concept of radians and moving around a circle just for a week, just so you can see why we're kind of doing all this. And then we'll go back to the theory behind it and where they came from and all that good stuff, okay? So first we're going to go back to the throwback to geometry, high school geometry, whenever you did learn SOHCAHTOA, and then why you were using it back then, right? So just as a refresher, SOHCAHTOA is because, you know, sine of some angle is the opposite over the hypotenuse. The cosine of some angle is the adjacent over the hypotenuse. And the tangent of an angle is the opposite over the adjacent. Now, remember, the idea was that you used to use these ratios whenever you wanted to solve for either the angle or the side of a right triangle, and you were only given a limited amount of information. So it's one of those things where you may have known a side and an angle, and then you were trying to find another side, or vice versa. So we're going to practice one of each just as a refresher from what you used to do. Then we're going to talk about how to solve non-right triangles, which is something that you never learned before, but you'll see that you can use these same trig functions to do so, okay? So let's just make up a problem where we have to find a side. So remember, this is just like old geometry that you used to do. So if I know that this is maybe 40 degrees and maybe this is 3, and you're trying to find the hypotenuse, okay. If this is a right triangle, and if I had given you both sides, then we could just use the Pythagorean Theorem. A squared plus b squared equals c squared. But whenever you're missing too much information, it's not possible to use Pythagorean. So instead, you get to use one of these three functions above. Now, what I used to do is to tell my students to choose an angle and circle it. So this is the angle that I'm going to circle because it's just the one that's already labeled. Then I label my triangle. So if this is 40, that makes the thing across from it the opposite. This would be the adjacent, and this would be the hypotenuse. So labeling is really important because then you look at what am I given and what do I want, okay? I'm given the opposite. I want the hypotenuse. So opposite and hypotenuse means that I need to look up here and use whichever trig function that goes with. So opposite hypotenuse, that would be sine, okay? So notice I looked for what am I given and what do I want, and that helped me decide on sine. So the sine of some angle is the opposite over the hypotenuse. Now I just fill in what I know. So I know that the angle that I circled was 40. So the angle always goes behind the trig function. And then O over H. So 3 over, we'll call that an X. You could call it an H, you could call it a C, you could call it whatever you want. I'm just going to go with X. And then from here, y'all, it's just algebra. It's just solving. I'll stick that over 1. Maybe let's cross multiply. X times sine of 40 equals 3. If I do a cross multiply, then I need to divide both sides by the sine of 40. And now it's a question for my calculator. I did not say this at the beginning of the video, but I should have. We will need a calculator for every single problem. So if you have a graphing calculator or even just a scientific calculator, please go get it now. Okay, please hit pause and go get it now. I'm going to do the same. So everybody grab a calculator. We'll meet back to finish this out. So I've grabbed my calculator and just took a second to go to mode and set the mode to degree. I know you know how to do that, but that's going to be really important because we are dealing with degrees, not radians right now. So please change mode to degree. And then we're just going to type in exactly what we see. We've got 3 divided by the sine of 40. And my calculator is giving me 4.667. I'm just going to go out to 3 decimal places just because. There's really no reason, just because. And so now we know that the hypotenuse is 4.667. Now, if you were asked to find like the next side and you already knew 2, then feel free to just do Pythagorean Theorem to find it. You don't really have to do another SOHCAHTOA, but you can if you want. It's really your choice, okay? All right, cool. So now let's go over to what if they want me to find an angle instead. So you know it's a right triangle. You know that maybe this one's 2 and maybe this one's 5. Okay. And let's say that they're like, okay, find this angle right here. Okay, so if this is the picture in question, we're going to do the same exact thing. We're going to circle the angle that's important, and then we're going to label our stuff. So they've given me, this would be the adjacent, and they've given me the opposite. And if they want the angle, we need to think about what was given and what we want. So what was given is opposite and adjacent, and we want the angle. And so because of that, with these two being our primary words, we need to use this formula for tangent, okay? So tangent is the opposite over the adjacent. And then we're going to fill in what we know. Now, for theta, that would be the angle that our formula has, but this says x. So let's change that to an x, okay? The opposite is a 2. So I'm going to just erase and change that to a 2. And the adjacent is a 5. And from here, there is no cross multiply. There is no rearranging even. This is called, fancy way of using your calculator. Anytime you need the angle, this is a good little note to put, need angle. All right, if you need the angle, this is where you use inverse trig. And all that inverse trig is you need to be hitting second and then sine, cosine, or tangent, okay? So inverse, that little button, the second button, the one that makes you do inverse, that's exactly what that purpose is for. It is just to work backwards and find the angle. So I'm going to hit second tangent of 2/5, and that's what I'm typing into the calculator right now. Let me do it actually. Second tangent, and then that was 2 divided by 5, and it's giving me 21.80, okay? 21, and I'll do my degrees rounded to 2 decimal places just because. Just make sure you give me a couple decimals here. All right, cool. So that's how that's going to work. Not too bad, I hope. And like I said, that is old stuff. Now, what's cool about precal is that you can find the information of sides and angles of any triangle, guys. It does not have to be a right triangle, and that is super cool. So when and how to use the law of sines. This is your next formula, is the law of sines. This is going to be to help you with non-right triangles. Okay, and it's going to help find sides and angles, just like we were doing above. And as far as the when do you get to use the formula I'm about to show you, this is when right here. These 3 scenarios, you may remember also from geometry, that when you're given information on a picture, you can classify that picture as angle, side, angle, 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 side, or side, side, angle. So an example of an ASA, I'm going to draw a very generic triangle, okay? An angle, side, angle means that they are giving you, like maybe they give us 22 degrees here, followed up by a side immediately attached. It could be the side above or the side below, so maybe they tell me that's 10. Followed by the angle right behind it. So they would have to have given me a picture that looks like this. And if they give me that, that would be an ASA. Now, an angle side. What would an angle side look like? Well, let's start in this same corner. Now we'll call it, let's say, a 35, okay? If it's an angle side, they have to give me an angle, then another angle right next to it. Doesn't matter which one. Let's pretend it's this one. And we'll do like 65 up there, okay? So they've given me an angle followed by an angle and then followed by a side. So it would look like this, and this is just, you sort of imagine reading it circular, you know, like start in a corner and then go around it in a circle, and whichever three things are touching, that's the type of triangle that you have. Now a side-side angle, we'll draw the same kind of a picture here, okay? A side-side angle, so we need two sides in a row followed by the angle that touches. So let's just start at this side. Let's pretend this is 7. This looks a little bigger. We'll call that 8. So here's my side, followed by a side, followed by, now we need an angle. So let's call that, that looks to be about 53. I don't know, we'll just call it 53. Okay, so let's let these be our pictures to represent the ASA, the AAS, and the SSA. So if you see one of these types of triangles, you get to use the law of sines. Now, what is the law of sines? You may be like, okay, this doesn't help me because I don't have a formula. Now you're going to get your formula, okay? What the law of sines says is that, well, let me write it and then I'll explain. Okay. Sine capital A over little a, sine capital B over little b, sine capital C over little c. What it says is that the way that a triangle relates to each other, everybody's proportional. And this A, B, and C, these are the angles of your triangle. These are the vertices. And you can really put them wherever you want. Sometimes people label it for you, A, B, C, or X, Y, Z, or whatever. But I just usually like label however I want. Now, the key and the most important thing to remember is the reason these are little a, little b, and little c is because they really do go with the angle above it. And what I mean by that is that whatever side is on the bottom is opposite or across from the angle up top. So as kind of a little cheat here, we could put the sine of some angle, and then on the bottom we need to choose the side opposite that said angle. Okay, so that's what these little fractions are, and that's how you need to label it on the picture. Now you get to work, this is your formula, and this is always true. So you get to label your picture and then decide how best to use this formula. And it's going to work best, I think, if we just jump right in and do an example. So if we come down here, you can call this whatever you want. I'm just going to go ABC because it really doesn't matter which one's A, B, or C, okay? Now, once I label this as capital A, you can go across from it and label that as little a. If this is a capital B, then this must be little b. If this is a capital C, go across, and that is little c, okay? So these are how, or this is how you label the triangle. Then you decide how to use the formula. So, when I look at this formula, just like before, I look at what is given and what do I want. Okay, what's given and what do I want? Well, I don't know what I want. This hasn't told me what to find yet. And so let's pretend that it was just solve the triangle. Like maybe they just wanted you to find a bunch of sides. But let me narrow it down because I don't like that. Let me pretend that this one said find little a. Okay, maybe the goal was to find little a. So if it wants you to find this side over here, then we for sure have to use this part of the formula because it involves a. Now, when we go to choose what to use next, we have a choice. You don't want to use all three of these at the same time. You either need to choose to use this one that involves B, or choose to use this one that involves C. Now, when I look at this picture, I am not going to choose C because even though I know the angle, I do not know the side across from it. The reason I'm going to choose B is because I know that side and I know that angle. And I know you're thinking, no you don't, that label is not labeled. But guys, you do know that angle, right? Because how many angles are in a triangle? How many degrees? There's 180 degrees in a triangle, and they gave you 2 of them already. So what I would do is start by taking 180 and subtracting 22 and subtracting 44, and I know that this is 114. So I can totally label that one myself. And now I know, well, I've got both parts of B, so I'm going to use B. So I'm just going to recopy this formula. Sine A over A equals sine B over B, and now I'm going to plug stuff in, okay? So capital A is 22 over little a we don't know. That's what we're trying to find. Sine of capital B, okay, that is 114 over little b is 10. So I'm just looking at my picture and filling it in. What should happen right now is out of these 4 pieces, you should only have one unknown, okay? Only one thing that you don't know. If you have more than one thing that you don't know, it means you're doing the wrong thing. It means you've chosen the wrong part of the formula to use. But from here on out, it's just pick up a calculator and solve. So, I mean, it's cross multiply and solve. So I'm going to do A times the sine of 114 equals 10 times the sine of 22. And then how do I get that A by itself? Well, I divide both sides by sine of 114. So this is just good old-fashioned algebra, rearranging and solving for the letter. And now this is what I'm going to type into my calculator, okay? This is not a lot of fun to type into your calculator. I recommend using, if you've got the new software, using alpha y equals enter. If you hit alpha y equals enter, it will actually give you a nice fraction to type into. And then we're just going to type our answer. So I have alpha y equals, and it gives me this really pretty fraction bar. And so I'm just typing into that right now. And then it's sine of 114 on the bottom. Okay, if you're typing this in right, you should get 4.1. And then it's a couple of zeros, blah, blah, blah. So it's 4.1. So hopefully you got that, and that would be our missing side. Pretty nifty, huh? It's kind of crazy because you've been told most of your life you can only solve a right triangle, and here you are solving whatever the crap you want. Okay? So now we're going to come over here and do another non-right triangle and figure out how this works. So here we have an angle side. Okay, so I'm going to go a little bit quicker now that we've kind of established how to choose things. I see the 11 and the 35 across from each other. So if I call that A and A, I'm going to go ahead and directly start writing out my formula. Sine of the angle over the opposite side is equal to, okay, well, let's figure out what they might want us to find, okay? Let's pretend that this problem wanted us to find this side, little c or something like that. So if that's what it wanted, we need big C so that we can find little c. So how do I get that? Well, I subtract these two from 180. So it looks like this is 100, so this one is 80, okay? And so if they want little c, if that's what's been find little c, okay, if that was the goal, then now I just use the angle opposite it, so sine of 80 over little c. I'm going to cross multiply. C times sine of 35 equals 11 times the sine of 80. I'm going to divide off the sine of 35. And I'm going to type that in and get an answer. So give me just a second to type that in. 11 sine 80 divided by sine of 35. Okay, I'm getting 18.89. And that does make sense actually, because the smallest angle is always across from the smallest side, and the biggest angle is always across from the biggest side. So that makes sense for this problem. Okay? All right, cool. And our last one is, let me put a little X down here. Let's pretend this was the picture given, and the 7, 8, 53, and they want you to find X degrees. They want you to find this little interior angle. If it makes you feel better, go ahead and label your A, B, C and all that, because some people might want to do that for a while until they get used to this. I really am accustomed now to just looking for angles and opposites. So for me, I don't care if they're A, B, or C. I would immediately start with, I know the 53 degrees, and I know the guy across from it. So I would start with that is equal to, I'm looking for this angle, so sine of X, because I don't know that, opposite the 8. And that would be how I set this one up. Now this one's going to be a little bit different to type in. We're still going to cross multiply, okay? And when we cross multiply, we'll have 8 sine of 53 equals 7 sine of X. And what's weird is that a lot of you are going to want to divide by a 7 sine. That is not allowed. These are stuck together, like they can't be separated. So all you can do is divide both sides by the 7 and get rid of that. And now this is the number that you're going to type in, and it's going to be equal to the sine of X. Okay, so this is kind of weird. So let's go ahead and type in this number, which is 8 sine 53, and it's divided by a 7. Okay, so this is a 0.913 blah blah blah. Okay, so this is weird, and that is definitely not an angle. But this is sort of like the thing we did up above. Remember when I said anytime you need the angle, you're supposed to be typing like second sine in? That's what you're going to do at this point in the problem. You're going to type in second sine of that 0.1927, whatever it was. That's going to actually give you the angle. So second sine of what was there before, I'm getting 65.89 degrees. 65.89 degrees. Hopefully you're getting that too. If you're not getting any of these same calculator numbers, check your mode. It means you're in the wrong mode, okay? Now, we are more than halfway through the video, but there is still one more formula to use on the other kinds of triangles that don't fit these 3 criteria. So if you would like to take a break and go to your practice problems, maybe you could just try the ones that you recognize as ASA, AAS, or SSA. Just try those first, then come back to this video and finish out the notes, and then finish out your practice later. So, for the last 2 kinds of triangles that were not mentioned on the other page, the SSS and the SAS, we have to use a formula called the Law of Cosines. Now, Law of Cosines looks really complicated. It is harder to memorize, but it's really easy to use. So with an SSS, that's really obvious. An SSS is, somebody has given you 7, 9, 13, something like that. And an SAS means that they've given you a side, then the angle between them, and then another side. So 2 sides and the angle between. So maybe it's like 8, 106, something like that, okay? And so those would be the givens. Now let me go ahead and mark what I want you to find in each of these so that we can talk about how to do that. X degrees, and maybe we want okay, so I've labeled X's on those 2 for, like, these are going to be the problems we use. And now how do we use them? Well, the law of sines will not work. First and foremost, if you try to do law of sines, there's always going to be too much information missing. Here there's an angle missing, and then when you go to do this guy, there's also an angle missing. Same thing here. If you set up law of sines, you're going to have a missing side and then a missing angle on the other proportion, and it's just not going to work. So law of sines is here to help. Now there's two versions of law of sines that your teacher's going to show you. It's the same equation, but it's rearranged. So for law of sines, whenever you are doing, we're going to do this one first because it's a little bit easier. Whenever you're looking for a missing side, so if you're looking for a missing side, this is the formula that you use. A squared equals b squared plus c squared. It starts to feel like a Pythagorean theorem, minus 2bc cosine of capital A. Okay, so see how long and ridiculous that is? All right. If somebody's already labeled A's, B's, and C's for me, I actually ignore what that person has done. Because to me, I only like to memorize one formula, and the way I see it is this right here is the side that's missing, okay? I use that as my missing side. And I know all of this other stuff. You have to know all that other stuff. And you do, because if you look at it, what has happened? Hold on, I lost the page. Hold on a sec. This is weird. Nope, not you. Hold up. Yeah, I don't know what that was except for weird. Okay. So hopefully we will get that under control. All right, so sorry about that. So now what? Okay, so where were we? We were looking at this problem and looking at this formula above it. So the thing is, you will know all this information because the missing side right here is already across from this angle that's given. So see how there's an A in the front and a big A in the back. Well, that means those are opposite each other. These are opposite each other. So my X right now is going to become my A. All right. Now B and C by default are the other two sides. I don't care which one is which. It doesn't matter. All you have to worry about is the sides, not the angles. So B and C, call them whatever you want. And then we'll just start filling it into this formula. So B squared, maybe that could be B. So 8 squared plus C squared minus 2 times the other two sides, 8 and 6, times the cosine of 100. So see how nice that is? Whatever you're looking for, the one across from it is, is the thing that goes in the back. And then this is just called type all of this into the calculator in one big string exactly as you see it. Okay? So I'm going to do that while you're doing that. Let's see if we get the same answer. Okay, 2 times 8 times 6 times cosine of 100. Okay, I'm getting a 116.67, and then this is equal to x squared, so of course we're going to need to take the square root of that answer, and I am getting x is 10.8, okay? And that makes sense for the problem because 100 is the biggest angle, and so this has to be the biggest side. So remember, guys, only use the law of cosines on these two types of triangles. If you're already confused because you're thinking, but law of sines is easier. You're right, law of sines is easier. I'm only going to use this on this kind of situation where it's a side angle side or an SSS. Now the SSS is going to look a little more complicated, but it's just this formula that gets rearranged because you're trying to solve for the angle now instead. Okay, so the way that you're probably going to see it written is like this. You're going to see the cosine of the angle is equal to this big old fraction. Now, what happens is, think about this equation and trying to isolate that. What would we have to do? Well, we'd have to move these to the other side of the equation. So it would be a squared minus b squared minus c squared, because we got to move those away. Then we would have to divide this off. And so I would divide by the negative 2bc. That is all that it is. So this formula, your teacher's going to show you, it's not a different formula. It's this rearranged. These are equivalent, these two, okay? But this is the form that you want to use for an SSS because, like I'd said over here earlier, ignore the ABC and just really think about the fact that whatever your angle is, you need to lead the problem with the side that's opposite it, okay? So in this problem, we're looking for x, okay? So we're going to have cosine of x because we don't know it. And the thing in the front of this fraction is the one across from the angle we're looking for, which means the 13 squared needs to go first. Now, minus b squared minus c squared, once again, it doesn't matter which one's b or c, you decide, all divided by -2 times that b and that c. Okay? And so we're going to type all of this in and get a decimal. And then once again, we're going to hit second cosine of whatever that number is. Okay? And that's going to give us our angle. So let me give you a second to type all of that in. I'm actually going to do it in one fell swoop. I'm going to go ahead and type second cosine, and then in that parenthesis, I'm going to do my alpha y equals enter, and I'm going to enter all that mess in. So on my top, I've got 13 squared minus 7 squared minus 9 squared. And on the bottom, I've got -2 times 7 times 9. And I'm going to close that parenthesis. Okay, I'm getting 108.03 degrees. And that's what I'm getting for my answer, and I really like it based on the picture that I see. Biggest angle across from biggest side. And so there you have it. So I realize this is a crazy long video. Hopefully you took breaks or tried the other problems, but if not, good for you. You made it for the whole video, and hopefully some of that's retained. Look at these notes as you're doing the problems you're going to need to. These will not be memorized. It's going to take a while to memorize, okay? But work on practicing using them and with that calculator, and we will see you later. Hopefully it goes well.